To begin. So hello everybody and a big welcome. Thank you for joining us for this discussion, which is part of the Research Assessment for Ethics, Data and AI discussion series. This series is a collaborative platform uniting various initiatives dedicated to advancing responsible research practices. Key partners include the Coalition for Advancement of Research Assessment, or COARA as it's more commonly known, ERIP Working Group, and the International Data Policy Committee of the International Science Council's CODATA, the Research Data Alliance's Data Visitation Working Group, and the Ethical Data Initiative, which is led by the University of Exeter and the Technical University of Munich. Today, our topic explores the profound impact of technology on scientific practice. I am Catherine Bailey. I'm Professor of Research Governance Partnerships at the University of Exeter and Operations Director at the Ethical Data Initiative, and I will be your moderator for today's discussion. This series aims to foster an enriching dialogue among scholars, practitioners and policymakers dedicated to navigating the complexities of an increasingly data-centric world and shaping the future of research assessment. So before we begin, I would like to address a few matters of housekeeping. This event is being live streamed and recorded, and it will be made available shortly after the event. We will send links out to everyone who has registered today. And after this introduction, we will move to the main panel discussion and then to a question and answer session. And during the question and answer session, we will endeavour to answer as many of your questions as possible. So please do use that chat function to participate, to ask questions, or to expand the debate among yourselves as well. But please do keep your microphones muted out of respect for our panellists. And we'd encourage you to be as interactive as possible in that chat box. So if everybody is happy, we will delve into today's topic. The world of science is undergoing a profound and rapid transformation driven by an unprecedented influx of data and analytical power of AI. Researchers increasingly regard this moment as something that is increasingly being referred to as the fourth scientific paradigm, which is a shift from traditional hypothesis-driven models to one of data-driven discovery, where insights emerge directly from the information itself. This new era has the potential to fundamentally redefine how research questions are posed, answered, and categorized. AI is proving to be a catalyst for accelerated discovery across various fields. Beyond accelerating breakthroughs, data-driven technologies are transforming the landscape of knowledge itself, giving rise to computational versions of traditional disciplines, for example, computational linguistics, biology, and astrophysics. And this development fosters an imperative for transdisciplinary collaboration as AI acts as a nexus for sharing knowledge and methodologies across previously siloed fields. However, this paradigm isn't without challenges. The rapid expansion of AI research has been accompanied by a reproducibility crisis where many study results are difficult or impossible to replicate. Another significant concern is the black box problem, where the inner workings of very complex AI models are becoming increasingly opaque to human understanding. And this lack of transparency hinders bias detection and trust building, particularly in high-stakes areas such as medical diagnosis. I'd like to introduce you to our fantastic panel of experts participating in today's debate. So if our panelists can start unmuting and turning microphones on, I will proceed with a quick round of introductions before we begin our questions today. So in no particular order, we have with us today Astrid Wissenberg, who is the Director of Research at the University of Exeter. In this role, she's responsible for the University Research and Impact Strategy, leading the research division, which includes the Doctoral College, Research Services and Technical Strategy and Operations. A key focus of her work is making knowledge and research accessible and usable, and she is a strong advocate for improving research culture and supporting early career researchers. She's also a member of the UKRI Infrastructure Advisory Group. And for those of you outside the UK, the UKRI is one of the biggest funders here in the UK. Cameron Naylan is a Professor of Research Communication at the Centre for Culture and Technology at Curtin University, where he is the co-lead on the Curtin Open Knowledge Initiative. His research focuses on the culture of researchers, the political economy of research institutions and how these interact with the changing technology environment. He's a prominent advocate for open research practice, including open access and open data, and was a contributor to the Panton Principles for Open Data and Altmetrics Manifesto. Professor Devika Madali is the director of the Information and Library Network Centre at UGC Inter-University Centre in India. An eminent academic and researcher, she previously served as professor of the Documentation, Research and Training Centre of the Indian Statistical Institute. And she's a leading advocate for open science, and her core expertise lies in knowledge organization, open data repositories, digital libraries, and semantic web technologies. Professor Madali has made significant contributions to global initiatives as an expert consultant for international organizations, including UNESCO, UNFAO, and the European Commission. So I will proceed now with the first question, but as we go along, if our audience have any questions that come up that they would like to ask the panel, then please do put those in the chat, and please do expand the debate as well in the chat there. So first question here, I would like to put to Professor Madali, and this is: in what ways is AI and data-driven research transforming traditional research methodologies, and how is this shift impacting global collaboration across disciplines? Devika, please.
Thank you, Catherine. Thank you for that kind introduction and the opportunity to be here today. That is an interesting question, but I must be very honest and say that this is still in transition. The entire transition to AI-based AI agents mediated services is still in transition, at least in my part of the world where I'm dealing with various services. But having said that, I see a huge opportunity here in utilizing AI for various things, data. For example, we are looking at the automation of process of data collection and data analysis, for example. So whatever is quite repetitive in nature and time consuming, these tasks will, of course, be handed over to the AI interventions. Also, the other a little bit advanced intervention or application I see in predictive and analytic capabilities that are coming in through the AI-based models. So I think these are the areas where I really see the transformations will happen. As far as the international collaborations are concerned, these can go either way, but we can positively, again, leverage AI-based interventions for collaboration and sort of simplifying and also tracking the various collaborative patterns, maybe. That is where I see the applications. Thank you very much.
Thank you very much. Would any of our panelists like to weigh in on this question? So in which ways is AI and data-driven research transforming traditional research methodologies? Astrid, please.
Yeah, I completely agree with what Devika was saying. I think I can observe that the way that we do research, the methodologies that we use are changing because of the opportunities that AI and data science offers. Now, it's not as if that's really that new. I think it's been happening over the last few decades, in particular with open data. It's maybe sped up a bit. The speed of doing that is bigger. But also, I think you can start seeing how it's really influencing a whole variety of disciplines in how they do their research. They can do it quicker. That means that they can ask more questions because they've got more time on their projects to do different things. They can pursue routes of inquiry quicker, but also just doing it in a different way and being able to ask different questions of the data that as individuals we've never been able to find the answers to. I think how that impacts different disciplines is very different. It goes across the board. It does raise risks, and I'm sure we'll come back to those later on today as well in this session. So I do think it is changing that. It also, I think, through that is opening up other types of collaborations than we have seen before between academic communities. So yeah, that was
Thank you
what I
very
wanted to
much.
add. Yep.
Thank you. So this is a very, very positive view, but I'd like to throw the question out to our resident AI skeptic, Cameron. What do you think of this question? In what ways is AI and data-driven research transforming research methodologies?
I think for me, I think the question about collaboration is really interesting. So there are certainly positives, right? So one of the things that is a big change is the ability to actually communicate across language barriers, across maybe time zone barriers through different technologies that make that easier. And you can sort of extend that to access to data, as Astrid was talking about. And I think the challenge that arises out of that is the extent to which, if we come to rely on those as crutches, are we doing the work involved in actually understanding? Because collaboration is not, I guess we'll come back to this, right? So a lot of what is labelled as AI is document generation. And when we're doing research, we're not doing research to generate documents. We write the documents to do the work to generate the insight to understand what we're trying to do. And so I think there's this whole series of problems where we run the risk of thinking, oh, this thing which was what we thought we were doing, writing papers, generating emails, becomes easier, but we've gone away from doing the actual work that matters. But then, from the technical perspective, there are many things we can do, and we can do easily and more easily and more quickly than we could do before. And again, as Esther was saying, this goes back a long way. I mean, the book, The Fourth Paradigm, I think is now 20, 30 years old. So this data revolution, what we used to call AI and what we now call machine learning, or do we call, I'm not sure which things we're calling which things anymore, but it's been a process we've been through for a long time. And so some of that's still bedding in and some of it's, there are opportunities, but there's a lot to learn about what's working and what's not.
Thank you. Thank you very much. So on to the next question. How can researchers ensure that data-driven approaches maintain the integrity and reproducibility of scientific findings? Cameron, I'm going to throw this one out to you to start with, please.
Yeah, so I think this cuts to the core of what I was just saying. The underlying principles of research integrity and reproducibility, and reproducibility as a form of integrity, haven't changed. They don't change. I think I point to Sabina Leonelli's work, thinking about not just reproducibility, but the core commitment we make to our work being transparent and auditable and critiquable by our colleagues, by those who test us and test our ideas and test our claims. So that means things need to be observable, they need to be auditable, they need to be clear. And at least if we're talking about the new generation of large language models, there are some real problems there. So at one level, if you want to do reproducible research, the answer when it comes to some of these more recent large language models, and particularly proprietary large language models, is don't. Because then you cannot make things reproducible. But if you're using them as a source of information, a source of data, then maybe there are things you can do in terms of, again, making sure you can make the data sets available, treating them as the outputs of these as experimental data. And so then that goes back to, again, the sort of previous generation of machine learning, neural networks. All of these systems have a lot of the same problems in terms of them being black boxes, as you said. Which are very challenging to tease apart, actually very challenging to share. And there the answer is, again, as far as possible, you're making sure the outputs are available, making sure the process is auditable, even if it can't be fully shared. And this is not a new thing in research. So if you think about research processes like ethnography, to use a sort of example from the humanities, where you go and observe and experience a setting, then again, there are things you can't share for ethical reasons in that context. And there is a whole tradition about how you make that as transparent as possible to make those insights, again, testable. And they're also, I think it's at core, if our commitment is to transparency, to clarity, to integrity, then all of these are just tools which we can use. I think there are some particular problems with some of these tools. So again, to go back to the large language models, proprietary black boxes where you're not allowed to share the results because the license doesn't permit you to do so, where we don't know what went into them in any meaningful way, then I think that's really problematic. And I think there's some really deep questions to ask about how that works. But I think there's also a deeper problem with these chat systems in terms of research integrity at its core. And again, it comes back to this point that what we do in research is set ourselves up to be questioned by people, to be critiqued, to be disagreed with. And these language models are constitutionally created in a way to agree with you. And I don't just mean in the way they're set up to attract users and to be easily marketable by being friendly. I mean, they're fundamentally built on the assumption that you take something that's been said and you continue it in a probabilistic fashion. And I think actually that cuts against our integrity, because our integrity should be about questioning, testing. And so I think there's something there to think deeply about. But in the broad sense, it's the same story as it's always been. Show you're working, be clear about your working, show where you're coming from, where you're going. And if you can't show it fully, then explain very carefully why that's the case. And that doesn't change.
Thank you very much. Astrid, I can see that you're reacting to this.
Yeah, I completely agree with what Cameron was saying. I think what I'd add to it is that it's really important for researchers, I think, to really think that through at the very beginning of any project, and to really consider it more seriously perhaps than they may have done in the past. So don't assume that because you've done your research training, you know what you're doing in your research area, that now you're using these new tools, that therefore everything that you used to do is exactly the same. So just consider that very clearly, how you use it, where you use it. Perhaps there are things where it might be tempting to use AI in some of the large language model tools, but maybe they're not appropriate for that particular area, because you cannot share those outcomes, because you cannot share how you've done it completely. So I think that early consideration and really thinking through what the impact is on your research, and the openness of that research and the transparency, and being able to be challenged and debate and discuss what comes out of your research is what I kind of add to it.
Yeah, that's a very, very good point. Thank you. Devika, would you like to add anything to this question?
Yeah, thank you. I also tend to agree with Cameron and I'm sorry, I'm not getting. Yeah, because reproducibility depends upon a whole lot of things. First thing is the policy level, as Cameron tried to point out, which may be barriers in themselves, which are created on purpose many times. And again, on the technical level, as long as we know these much celebrated and discussed LLMs, how they actually function, is it transparently documented? Are the workflows also very transparent? If that's happening, yes, I would agree that reproducibility is something that is achievable. I know that at a lot of discussions and conference, we always talk about reproducibility as though it's a given. But it's not so much that when we go into the box and try to unravel each strata, we understand there are more complications to this. So we have to sort of, in my view, address each strata very minutely to in the end arrive at really the grand plan of reproducibility. That's what I had to share. Thank you.
Thank you very much. The next question here, and actually before I move to the next question, I'd like to remind the audience that if you have any questions that come up as we're discussing, then please use that chat box to add your own questions, and we'll come to them as we go along and or at the end, depending on what's most appropriate. So our next question, and I would like to put this please to Astrid. What challenges might arise from integrating computational disciplines, for example, data science, bioinformatics, or computational physics, with traditional research fields, and how can interdisciplinary collaboration be fostered in this context?
Thank you, Catherine. And I'm going to take a very kind of institutional focus on this in terms of what we can do around this. I think for me, the key here is that you're bringing different groups of people with different experiences, different traditions together. Bioinformatics has its own tradition. In itself, it's built itself up. Data science has its own traditions alongside those more traditional research fields. So needing to cross boundaries and needing to cross different research cultures that people have means building bridges across languages, across methods, and really enabling people to come together and do that. So that means providing platforms where people can do that, providing funding with which people can do that. But it really requires from the communities a willingness to be open and to understand each other and build a level of mutual understanding, and that can take time. I was thinking about this in the context of that there are different models of how we do this around, and I was just going to pick up on two very particular ones, which I think are different ways of approaching this. One is where you really embed and integrate data science and AI and research software engineering within a discipline, and bioinformatics for me is a really great example there, where you bring the disciplines together and they generate a new discipline together. So very, very integrated. Usually this is really effective in terms of doing research. People have built a common language and a common culture and a common community. But it does require investment. It does require recognition to keep that going. I think everyone will recognize that bioinformaticians don't always get the credit they deserve on projects, for example. So it's not without challenge. So it does build that close connectivity, but it can also in itself become, again, a silo, might become very separated from wider AI data science developments, for example, or other work in the biosciences sphere. So you have to be thinking about that. And it can be potentially not so resilient because you often rely on real deep experts, of whom there is a limited number. Another model, and this is something that we've been experimenting with in Exeter, is to create an expert data science and AI group that actually can work across multiple disciplines and projects. That means that that's a more resilient model because you've got more people, they are more fluid, they can work with different communities. It brings wider expertise into the mix, which can help with broadening that interdisciplinary culture in itself. But the cons of that model is that it will take more time to embed those people in particular research projects, and you will always have some barriers and some work to be done about bringing those people together. But it is really important, therefore, to then involve those people quite early on in terms of project design. So I think there's a multiplicity of ways that we can overcome some of the challenges of bringing different cultures, methodologies, and communities together. But it does take investment, time, resourcing, and commitment from everyone to do that, and an openness, a commitment to openness to do that.
Thank you very much. And that's some really interesting insights, really, from kind of university management and how these things can be done in a more structured way. Cameron, I'm going to bring this question to you now, if I may. What challenges might arise from integrating computational disciplines with traditional research fields?
Yeah, thanks. And I'll actually, I think, sort of follow on from Astrid's sort of institutional perspective, a researcher one, and also looks at some of the opportunities. So I think the cultural challenges, the challenge of differential access to resources, can be expensive stuff. So in that sense, that can be problematic, and that can be problematic within an institution, with faculties with less resources than those who are used to having big computers and big iron and whatnot. But to Ashley's point, I'm going to call out. I should say I'm actually no longer at Curtin, and the current lead of the Curtin Open Knowledge Initiative is Carl Huang, because I know there are some colleagues on the call. But I do want to call out one of the things Curtin's done, which is to build the Curtin Institute for Data Sciences, which is a capacity for data science and software engineering within the university that's available to researchers. And the work we did and are doing at COKI was really only made possible and massively scaled up by access to that expertise and those resources. And so I think there are real opportunities with providing those capacities in ways that are well configured. And again, this is kind of what we were doing as more traditional data science. But when we started, some of the things we were doing around machine learning and categorization they were labeled AI at the time. So it kind of fits. So I think there are massive opportunities in recognising the strengths that different disciplines bring and the different expertises bring. Two examples of that. Work by Ithaca SNR noted that research communities that are places and sites of successful and large-scale data sharing tend not to be disciplinary communities. They tend to be communities that have come together around particular kinds of data that address a particular problem. And I think that's really interesting because the data sharing at its core is a collaboration problem. And to expand that up, I think what we did at COKI when we started was to really think from a humanities perspective, how can we work with the data? And this was really interesting because data scientists, software engineers are used to thinking in a scientific, objective, the data is what the data is. No, you don't question the data. Whereas the humanities would say, well, who collected this data? Whose interests are served by analysing it this way? And so, as the sort of glib way of doing it, humanities is really good at framing questions and thinking hard about the questions we're asking. The sciences brings a whole set of tools to answering good questions in ways that we try not to fool ourselves. So that connection, I think, is really valuable. And again, I think the Curtin Institute for Data Science is a great example of a success in that kind of space. And I would encourage other institutions to think about ways of trying to replicate that.
No, this is a really fantastic point. And I know kind of at the Ethical Data Initiative, we bring in lots of different disciplines really to sort of solve problems and kind of ask questions. And there really is a lot of benefit really to having lots of different ways of thinking about things, in terms of solving problems. It seems to sort of add another layer to it altogether. So thank you for bringing that up. Devika, please, would you like to give your perspective on this question?
Yes, thank you. About the transdisciplinary and multidisciplinarity, I mean, that's the only way to go. It's very obvious that no longer we can call very narrow focused silo-based research to go along. But having said that, my mind thinks about all the practical problems, at least where I come from. Traditionally, research has been done in earmarked labs, which were discipline centered, the disciplinary groups, so to speak. And now to sort of make the same into multidisciplinary approach or groups is a challenge. The transition is a challenge. However, having said that, the university systems are most suitable to quickly transform themselves and form these multidisciplinary groups rather than highly focused niche area laboratories, which are finding it much more difficult to actually allocate resources, find capabilities, and then build the groups around that. So in that way, I think at least in India, the multidisciplinarity is growing around the groups that are working within universities very naturally, and the specific discipline-based laboratories are taking their time to form this. So that's the situation I would like to point out. Thank you.
Thank you. Thank you very much. So just to remind our audience, if you have any questions, if you could please put them in the chat, and then we'll get round to them as we move through. I can see that Talia has put a question in the chat here, and I'm kind of wondering if you could maybe expand on it. So if Talia, if you could, if you are still with us, in fact, if you could unmute yourself perhaps just to expand on your question, because it's sort of very, very interesting, but I just want to make sure that I don't get the context wrong there. Okay, I'll just sort of assume Talia's not with us right at the moment. The question here is around the black box effect and how this, of course, if we're kind of feeding information into the AI machine, sometimes even the programmers don't necessarily know what is going on within this sort of complex structure. And we don't necessarily know kind of what biases have occurred really, and kind of what the output is going to be. So I'm going to look to Cameron here to see if you could give a little response to Talia's question.
Yeah, well, I mean, this is the core question, and I think it's got two layers to it, right? One is the simple, the black things that are black boxes themselves, and that are therefore, we don't know what's going on inside them. We don't know how they operate, and that's just problematic for any kind of scientific study. You don't bring a stochastic method to a situation where you need something which is deterministic, and we don't add randomness to our experiments. Well, I guess there are times that we do add randomness to our experiments for very specific statistical reasons, but we do it directly, not at random. So I think, that's kind of just the basic, and this is not specific to AI. It's a problem. It's been a problem, for instance, in chemoinformatics for 40 or 50 years, where the proprietary providers of some important code have never allowed anyone to actually test or benchmark those systems. That's been an ongoing debate for a long time. So that's kind of just a sort of methodological, ethical problem. But there's also this sort of question of responsibility, which is, and again, if we're talking about the big language models, which we know are built on stolen content, we know they're built on biased and offensive content, and that they contain very, very serious biases of the forms that are problematic in our society already. And if we don't know how those things are going to be expressed in the results of a system we're using, and again, this isn't specific to AI at all, then I think we have a responsibility to, again, act with integrity in terms of what we're using and how we use it. And then in terms of the negative effects on scientists, I think the sort of assumption that these things can be trusted. I mean, again, as a scientist, as a scholar, our basic position should be we don't trust anything. So yeah, that's kind of that. I guess that's the way I sort of responded. But there are layers to this. But also, it's not new. The problems are not particularly new in that general sense. The things we've faced before, and we'll face again.
Thank you very much. There's a comment here from Rasak in the chat that the knowledge on the ethical use of AI for research is gaining ground across disciplines. But could you perhaps explain further the application of AI study on ethnography, which is something that you did mention earlier? And then I'll throw it out to the rest of the panel for their comments, because this is a really interesting question.
I guess I wasn't really thinking of AI in ethnography. I was thinking more ethnography as an example of a discipline where it's not strictly reproducible, but there are standards of evidence that you bring and approaches that are brought to how you describe the evidence that you've gathered in an ethnographic setting. It's an interesting question, though, because obviously if you've got as you often do in an ethnographic setting, notebooks and notebooks full of text that's been written down or recorded, or recordings, or these kinds of things, then the process of transcribing, the process of gathering data out of that, again, traditionally very sort of arduous hand process, manual process of drawing data out. And then if you use, for instance, a language model to process and pull information out of that record, that transcript, and you don't know whether that's reflecting the balance of what is actually being recorded, then there are potentially very serious problems. And this is one of the examples of this, not quite the same example, but the use of algorithmic systems for suggesting sentences in criminal proceedings, where it's been demonstrated time and time again that those systems have a very distinct tendency to be biased against underrepresented groups and to provide harsher penalties to people of colour, to women, to other underrepresented groups. So if you think about that as the thing which is giving you your transcript back from your study, then there are some questions we need to ask ourselves about how much we trust these things. And again, it's the work of processing those transcripts is part of what our sense making, our research itself.
Thank you very much. And yes, thank you very much to our audience member there, Rasak, for introducing this into the debate, because it adds a completely new dimension. Astrid, would you like to add anything?
Maybe two things. Well, one comment and reflection on what Cameron was saying and on the question, but then also a question maybe back to the whole group. So I think there is something that, again, this is not new in a way, and I think Cameron was saying that as well. And I'm thinking about oral history, which as a historian I've got more of experience with. Even however well you transcribe conversations, video them, you'll never get the richness of having had that conversation with an individual across. So there's always an element of a black box. And if you go back 20, 30 years, we wouldn't even have had recordings. We'd have only had any transcriptions, and even that wasn't necessarily the culture of doing. You kind of wrote up your results, but you never really necessarily provided the data. So we have made progress almost. And that's a good thing. I mean, you shouldn't forget about that. That's not ignoring all of the dangers around some of this. A question I've back, and this is where my technical knowledge is relatively limited, but we are having quite a lot of discussions around whether providing closed environments with our own large language models, where we put the data in, we train it, is more safe. And that's partly driven by security considerations, kind of agendas around internationalization of research and where you want to keep your data, etc. So it goes a bit against open data, but okay. It does give a trusted environment, and an environment in which you can determine what those language models actually do, and you can train them on a core set, which could prevent some of the things that Cameron's talking about that bias that is built into the generic tools. And I'm just wondering if anyone has any experience with that and think that's a better way to go, but noting you still have a black box, because then you have a black box sitting within one university or one research group. So I'd just be keen to understand if people have got experience with that different way.
Maybe this is something we can throw out to the audience as well. So if anybody has experience with, if I've understood this correctly, using trained models or closed models really for this, to add that extra layer of trust really within the research environment, if they could perhaps raise their hands or give us a little sign. I'm going to hand off quickly to Cameron, who was smiling through that, who may be able to answer the question.
I think, well, so one setting, I know this has come up. So I'm currently in Sweden. English is not the language of the folks around here. So as in common with a lot of, in many parts of Europe, people are developing local language, large language models with a kind of similar intent. And I think it's interesting because there's two different things going on there. One is the model of the language. And this is where these large language models are really powerful, is that they are really, really good models of language. And so if you're doing things that involve parsing out parts of language or reformatting or rephrasing, that's what they're good at. I guess what's interesting to me is that there's also this implicit thing that if you train on your local language, you're also going to imbue it with your local culture. And I feel like that's a category error because you're shading into the problem that these things are thinking, that they're not thinking. It's best to think of them as an autocorrect. They're putting the thing in that the read ahead, the most likely response, and so I think there's a challenge here. I think the real opportunities are going to arise when we have the capacity to train these kinds of systems for very specific applications. That's where I really see the potential. And the challenge with that and building closed systems within an organisation to try and do things in general, I think is that you hit a scaling problem. It's really difficult to have the capacity, the resources to train. And this is before we talk about environmental consequences as well. That's another whole can of worms. But I think there's a challenge there. If I'm right, people can argue with this, that you want focused, purpose-driven models, then ideally you want those to be as good as possible for solving the problem and to be as transparent as possible in a research setting, at least. And that's different from building a system within an institution. So I think there's some scale challenges there potentially. But I'll give finish with a little anecdote. One of the colleagues in the Koki team did this. They trained a language model on our internal documentation. And what it was really good at was finding the inconsistencies in our internal documentation. It was not very useful at answering questions about our documentation, but it was really good at finding things that we tackled in slightly different ways in slightly different documents. So again, the language piece was what it was strong on, finding things that should have been the same but weren't.
My background is linguistics, so I'm just sort of going to put it out there that in fact it's not necessarily that the culture is shading in the language, it's that the language and the culture are built at the same time as one. And so there's kind of quite a lot of grammatical devices, for example, within languages that really show how people of that culture think about the world and kind of interact with the world. And yeah, I'm not going to go into it now because it's a completely different subject, but it is an absolutely fascinating thing to look into. Devika, I am going to please bring you into this to discuss this issue of this, oh dear, my goodness, and I've lost it here, of ethnography.
I'm still around, but I do not know how much my data will last. Thank you.
Okay. But if you could weigh in on this question, because it is a really interesting question. So I'd like to thank our audience member there for bringing it into the debate. But how ethnography is sort of perhaps an issue within this idea of a black box effect.
Now, I must say very honestly that I'm not an expert on the ethnographical issues, but yes, I'm just exposed to some of these, that the black box effect that we face in the research data transactions nowadays. As I already said, it really depends upon how much transparency and methodological and structural ways we build into the system itself. That's one thing. The other is the policy-based possibilities, which allows us to be transparent. These are important to tackle the black box effects. Like I did hear what Cameron said, and then my mind went back to like 28 years ago when I did my research, and I called that AI applications 28 years ago. And that was the classical AI that we were talking about those days, and we built rule-based systems, logic-based systems, frame-based systems, and this is what we called them those days. And even those days, when we talked about particular systems in particular domains, purpose systems, they worked fine. When we talked about general purpose problem-solving systems, I don't know how many of us remember these, the same level of success we never achieved. So yes, nowadays the tools that have emerged are much better. Again, the example Cameron gave, that these systems can pick up inconsistencies, for example, that the humans can't pick up quite that efficiently. So these are the good breakthroughs that we have had today. But again, the grand problems still linger, in my view, linger on. Yeah.
Thank you. Thank you very much. So there's a question here from Dario in the chat, which I think I'm going to bring in here because it's quite relevant to what we're talking about. Whether there's any frameworks being put in place in order to evaluate AI in scientific practice, and kind of at what stage this framework might be. Cameron, please.
I mean, I'm aware of some efforts to look and test various applications of various systems in places like, for instance, the assigning of referees into peer review processes. And it's been some interesting experiments. They're quite specific. And I think that's probably a characteristic of both where we are, and I guess you would pick up from my earlier statement. I think that's a better place to look, is not to ask, is AI good for science, but is this specific language model good for this particular task, and what are the limitations on that is for me, a much better question to ask. And I think it's interesting, and this is on the edge of my knowledge and expertise. There are these broad challenge-based approaches that are being used for assessing, particularly the language models. There are some standard tests. And what I've seen is quite a lot of criticism about not just the technical aspects of the tests themselves, but even the way they're designed and run. That again, they're asking questions in the wrong way, and creating some of the bubble that's around this at the moment. So I think there's some questions around what testing looks like, and what's our mental model of what these things are actually doing, and what it is we're therefore trying to test and validate against. And so for me, I would be much more interested in how does this tool work with this problem, rather than very sort of broad claims about, this is good for a whole domain.
Thank you very much. I hope that goes some way to answering your question there, Dario. Oh, yes, definitely, Dario says in the chat. So our next question here, in the interest of time, I would like to go with question 5, so it's not quite in order, just in case Devika does sort of run out of connection. So what strategies can researchers adopt to mitigate data security and privacy issues when using AI?
Yeah, yes, there's a lot of, first of all, apprehensions around the use of AI. And yes, I do agree, if we take some formal procedures and methods to mitigate the fears, that would be much more reassuring for the researchers. For example, something like having the AI-based blockchain technologies deployed, for example, disambiguation of data, for example. These are some of the techniques we might have to adapt to gain trust of these stakeholders in using the AI systems. Thank you.
Thank you very much. Would anybody else like to weigh in on this question? What strategies can researchers adopt to mitigate data security and privacy issues when using AI and data-driven tools? Astrid, please.
So I think one of the very practical things is again, and I think we said this before, really think through what you're doing. And that probably requires a certain level of understanding of what some of the particularly generic tools out there like ChatGPT and others really do, how they use the data, etc. And I think there are lots of researchers who are very familiar with AI tools and how they operate and how they work, and they understand what they do if they put data into one of those generic tools. But there are also a lot of people who don't, and who haven't been trained, who just think this is I'm just asking something to analyze a bunch of data, but actually not realizing that they're handing data over, that data, unless they remove it again, is then reused. And I have seen examples of that around me, which means that data that under any national laws or regulations should be kept secure is then no longer secure. So for me, the biggest thing here is probably what researchers can do is train themselves in their understanding of what actually these tools do, and what they do with the data, and to then go back and apply that to actually the research that you're doing and what the implications of that are when you want to use these tools. Because I do think that for the wider community, there's a lot of misunderstanding still, because we're still at the very early stages of some of these tools being really used on a day-to-day basis.
Thank you very much. And just going back quickly to our question 4, as we had planned it out, and I'll start asking this to Cameron, please. How can educational institutions prepare students and researchers to use those AI tools responsibly and critically?
I think this security question is actually a good place to start. In the sense of, I think I sound like a broken record, but there are a couple of different layers to this. There's kind of the glib answer, right, which is we need everyone to think critically. We need to think about what we're doing in the university. What is our purpose? What are we trying to achieve? Both for students, and for researchers and as researchers. But then we've got to deal with the reality of, yes, everyone should know about the threat model for the release of privacy data, and understand you don't put your clinical data into a third-party system that hasn't been audited by a professional. But in reality, when you've got one of these systems, I mean, I've got 3 or 4 different institutional systems up on my screen at the moment. I've tried to turn the AI off in all of them, and it keeps coming back. I know one of them, Microsoft Copilot, has by default a level of access to SharePoint systems, which is terrifying. And I also know of cases where SharePoint and OneDrive systems have been misconfigured in terms of ethics guidelines for privacy relevant research, not massive research breaches, but things where it's problematic and difficult, because these things are difficult to set up. And so it's really challenging even for corporate IT, for the IT professionals to have these things set up. So I wonder whether we even have the expertise to address some of these questions. But then, I know this is getting into tinfoil hat territory. These companies are not set up to serve us. We are not the market. The market is the much bigger corporations, the much bigger markets. There's an old joke that used to go around someone trying to persuade the lead product manager for Microsoft Office to include something that was relevant for researchers. And their response was, look, mate, that's a $0 billion market. I'm not interested. And And so what are the markets here? And the markets are the big corporate sucking up of all of this data to create the next generation of models, which can then be sold back to us. So I think there's a problem. We have to actually think adversarially with the providers of these models. We know they're unethical, fairly well demonstrated at this point. Look at yesterday's news as an example of that. So we have to think not just about the expectations we have of people to have the technical skills to make these decisions, but the systems in which they're working and operating, and whether they can be expected to have the kinds of level of knowledge required to make good decisions, and the fact that actually, we're being sucked dry as the product to be sold on to continue this financial bubble. So I think that's true. That's true of the security side, and it's true of the training side. These aren't new things. Again, we had the same conversation in teaching. We had the same conversation about Wikipedia. We had the same conversation about the web. And the answers have always been the same, that good teaching is teaching people how to do things, not how to pass exams and create documents. How do we get to that? How do we construct our systems so that, I like the analogy, you can take a forklift into the gym and you can definitely lift those weights using the forklift, but you're kind of missing the point. And so how do we persuade students in the first instance that the doing of the work is what they're getting value, it's what they're paying their fees for? And in the researcher space, how do we persuade people that it's not about churning out another paper or another grant proposal or whatever it is that we think our productivity measures should be, but the real work itself is valued, because then we can use the tools effectively. If we know we understand what we're trying to do and we're rewarded for it, then we can make good decisions about how to apply the tools. But it's a real challenge because we've industrialized these systems. We've turned ourselves into cogs in machines. Our universities are very effective at framing things as machine-like engineering problems. How do we get more money, more papers, more ranking points, whatever it might be, more students, more overseas students, less overseas students, whatever the government wants this week. And so it's very instrumental. So I don't know how we recapture that values-led process at an institutional level. And I know that university leadership have those values and hold those values, but the reality of the big gap between the top of expressing the values and the middle and the bottom of living day to day in an industrial system creates these big gaps that are really challenging to address.
Thank you very much. Yes, a lot of questions, a lot of problems, but it's really fascinating. And you've kind of brought up a lot of questions that really do need addressing. I have a feeling that Astrid might like to weigh in at this point.
That was so interesting. I was wondering if you were a spy in my university at some point, Cameron, in terms of some of the discussions and debates that we've been having. I think, I completely agree with the description of some of the challenges around it and how we do that. And it's so complex. I think that there's probably maybe two things to add. I think we may have a tendency as institutions to try and find a one-size-fits-all model. And I've seen that in my own, that what we do that allows us to use our own data on how we do our own business in the same way as what we do for our students in our education space, as what we do in research space. And I think slowly we're getting a much more articulated and sophisticated understanding around some of that. And I think that in particular in the research space, we have to really understand that, again, it's not one size fits all, and how research use and operates AI and how we support as an institution people in doing that has to be different. And we've had a fascinating debate around, in particular, limiting the tools that people should be using. I mean, you can never completely stop people from using other tools, but trying to say you should only be using the ones that we offer you because we have validated and tested them. Blimey, that's a difficult one to land. But I think what came out of it, that there is a community of a part of our research community that actually values that, because they feel that they then can go to a more trusted environment they can feel safer in. Whereas we also then have colleagues who like to develop these things themselves, and that, like, you can't tell me what to use. You can't tell me which bits were going to be working for my community and my problems. So I think there's quite a lot of conversation that needs to happen there, that institutions themselves need to create and need to value the voice of their researchers in that and the expertise that they bring. Yeah, I don't think I've got much more to add. I'll put in the chat a link. We've been working very hard on guidance on what you can do, and it's very much a living document because everything keeps changing. But there might be things in there that people on this call can learn from, or can perhaps criticize, or think, well, that is not helping me, or that's wrong. But it's just one of the examples that almost every institution is trying to write these things now. And yeah, it'd be interesting to do an evaluation actually of those things and how effective they are or not. But I could see a nice
Definitely.
research project there.
Thank you very much. Thank you, Astrid. So on to the next question. How can funding agencies encourage innovative and ethical AI use in scientific research? Astrid, if you'd like to kick us off with this.
Yeah, thank you, Catherine. And I spent about a decade as a research funder, so this one is close to my heart. I still like to remind old colleagues on how they can do things, and my view on how funders can really have a major role in shaping how research communities can go forward and reshape themselves. So I think we all know that funders can be very influential in setting expectations around how research is done. So setting expectations about being transparent, addressing those security issues, setting expectations on how AI use is legitimate or not legitimate in research. And for example, UKRI, you mentioned them before, Catherine, is the largest public funder in the UK of research. They have a statement on where they do and don't expect AI to be used. It still will be evolving, and other things will be added, but it starts setting a kind of a baseline expectation. I think that's really important, that they set the expectations around ethical use of AI and reproducible use of AI where they can. I think there is then something around their own processes, and again, most funders are looking into this. So how does peer review capture and review use AI as part of that? How do you train your peer reviewers to review projects that use AI in a proper way? Do they have the skill set and the knowledge to do that? Question mark. Probably needs quite a bit of upskilling of the peer review community as well, and noting that most people do this under lots of time pressure in their own time. So it's a collegial duty, but you do want that to be done to a high standard. So using AI in our own process and being transparent about that and improving the quality of that use of AI where possible. And then there's, I think, something around how they shape funding opportunities. So this is the more interesting bit. So obviously, some research funders will be very interested in how you develop AI itself and putting a lot of resources into that. But I think they can also think more about how you encourage the use of AI in areas where there is a real potential for innovation. So think about healthcare and applying AI to healthcare. How do you encourage that? How do you bring those interdisciplinary communities that we talked about earlier on together through funding mechanisms? How do you encourage people, incentivize people to have those collaborations and discussions? And I was thinking, link back to what Cameron was saying earlier on, when I was talking about those closed models from an institutional perspective, and you were talking, Cameron, around, well, that's not the right level. Well, maybe this is where funders can have a role in bringing particular communities together. So you could imagine more closed environments around healthcare, where there are agreements on what data goes in, how you use the models, etc. Where at least within that community, you can test and challenge each other. Again, it's a semi-closed environment, but it might make it more secure. So there's a balance there. So I think there might be something really interesting around that. The last thing I wanted to say is really funders need to think about the people and the capabilities and the capacities that our research community have. So think about how they build some of these newer tools into fellowship funding, for example, helping our early career researchers in particular in using responsibly and ethically these tools, and making sure that that's recognized and that people have time to develop those skills within fellowships, have time to work with people across disciplinary boundaries. And maybe also think around skills funding more generally around this. So we used to have in the UK a very vibrant landscape around discipline hopping grants, where if you had been in the biosciences and you wanted to go into medical sciences, you could get a grant for spending 2 years to kind of reskill yourself into that new area. And I'm wondering if there are models like that funders could use more to kind of build that capacity and capability in our broader research community. And a lot of these things are happening in other countries as well. I'm using the UK examples because I'm familiar with them. But I know they're happening in other countries, and I also know that they are part of a lot of the international collaborations that happen as well between countries. So I think there's real opportunities there for funders to really incentivize people to use these things in the right way, but also to build that skill set to do that.
Thank you. Thank you very much. Cameron, would you like to weigh in?
I think, yeah, there's a lot in there. I just wondered what is specific to AI in this. So if you ask, what can funding agencies do to encourage innovative and ethical research? Is there something specific to AI? Because I think a lot of things, the challenge, I think Astrid's just described it really well. There's this challenge between, one answer to that question is usually, well, they should get out of the way and let the researchers be creative. And so not direct things and allow people to, and that, it's a logic in that. But at the same time, creativity depends on the capacity you have to do things. So funding those capacities, the centralisation, the standards, the trusted, validated places that people can work and not have to worry about that part of the problem, obviously is resource intensive. I mean, you're thinking, maybe a good example is medical research. So we have a very significant investment in secure systems to support medical research. And I know the people in the audience will take me to task on this, but to a certain extent, that's a solved problem. We have an institutional solution for managing these things. So helps resourcing the AI aspects of that, or the application of large language models to metadata enrichment in the context of those clinical trial databases makes sense. But yeah, I think I'm a great believer in this notion of the person and the community that comes from moving across boundaries. So that's where I think that's as true of the technical and creative side as it is of the ethical side. If we believe in equity, diversity, inclusion, it's in large part because by being in contact with people with those different experiences, we learn to care more about different experiences. So I think that process of learning more, again, not specific to language models or machine learning or any of these things, but I still think that's a valuable thing to focus on.
Thank you very much. So our final question, I'm saying final question, actually, there are two more, excuse me. So what future developments in AI are likely to have the biggest impact on scientific disciplines in the next decade? And how can the research community engage with policymakers to shape relevant regulations? Astrid, please.
Yeah, I think that the future developments and biggest impact on disciplines, I don't know. Yeah, that's crystal ball gazing that I find quite difficult to do. And I'm sure lots of people will come up with different examples from their own backgrounds and their own research interests where they can see a really big change happening in that sense. I think in terms of engaging with policymakers to shape relevant regulations, there's a lot in there because first question would be, well, which policymakers are we talking about? And obviously there's around the policymakers that are involved in how you do research, those policymakers. But there's then also the policymakers around the broader societal use of AI. And that bit I think is really interesting. And there's an interesting experiment happening in the UK at the moment with a lot of international partners as well. Again, I'll put a link in the chat in a minute, where they've created a evidence synthesis hub that is going to use AI to analyze all scientific evidence to provide policy advice to the broader policymaking community. And I think that's a really interesting example of where AI is being used to influence policy. But I don't know to what extent then the ethical constraints around that are being understood by all sides in that community. What I would say is that very clearly we have got in the research community experts who can have conversations with government officials, with policymakers around how AI is used in the right way. And generally we do that. We raise our voice, we talk about these things. As someone who's worked a lot with government policymakers, it's just about finding the right times and the right entry points and presenting your evidence in a way that is helpful. So that synthesis bit is really interesting because that is what policymakers are looking for. They don't want your lengthy article in a large, well-established journal. They want your 3 conclusions, what they need to be looking for. Now, what they really need is somewhere in the middle of those 2 things. So for me, this is around our community proactively engaging with policymakers and understanding what their questions are at the right point in time. Sorry, that was a slightly rambling answer, but there's a lot of ways of tackling that question.
No, I mean, it is incredibly insightful because it is just about asking or giving those talking points just before they go into the important meeting. And yes, there is a lot of truth in that. Cameron, please, what's your view on this?
Yeah, so I think, I mean, from a skeptical perspective, I think there's a lot of opportunity for scholars, particularly in the humanities and social sciences, to build up credibility for the future when these things go wrong. I don't believe we're going to have an impact on the uncritical adoption of these things in some settings in the immediate future. But I think there's I would point people to Cory Doctorow wrote a really interesting piece reflecting on a talk he gave a couple of weeks back. And I think he had some really interesting things to say, whether you accept his analysis or not. But thinking through how these things play out into the future. So my problem with these sort of evidence synthesis approaches is that this is why I'm a skeptic. Every time I've seen one of these things that claims to be drawing a whole bunch of information together and telling us what the answer is, every time it's been wrong. And it's getting less frequently wrong, but it's getting wrong in increasingly subtle and dangerous ways. The worst case of this was a summary of one of my own papers, which confused me quite a lot about why I hadn't done an experiment that it said I had done. So the summary said I'd done this experiment. We hadn't. And I couldn't figure out why for quite some time. But the problem was it didn't make sense. The experiment didn't actually make any sense to do. It would never have worked. And that's obvious if you start from the right place. But I was completely confused by the summary in a way that led me down the garden path. So I think there's something really dangerous going on here in terms of the assumption we can use these for summaries. And so there's an opportunity there. I think the other big opportunity, because I got another negative one, and this is again from Cory Doctorow's point, this is a financial bubble. It is going to burst. The models don't go away, so that useful tools potentially suddenly become really cheap and really available. GPUs suddenly cost almost nothing. And so the potential, if you're positioned to take advantage of the useful aspects of these technologies as a financial bubble crashes, are really quite high. So that's an interesting thing if you're that kind of opportunist. But in terms of the technical developments, in terms of the things, I mean, the language models themselves surprised everyone. No, that was completely, no one was expecting that kind of shift in technical capacity in that time frame and in that way. And so I think what that tells us is making predictions about not just the technical capacity and how it's sold, but what it's actually useful for once we figure that bit out, I think is probably a fool's errand. What's clear is the sort of shape of what's emerging in terms of the fact we're running out of data to feed these things. We're certainly running out of coal to burn to keep improving the models. So how can we use them more efficiently? So the opportunities are going to come in efficiency, and to my mind, application and specificity, because these are powerful tools. They do a lot of things really, really well. And so the impacts are going to come from spotting those opportunities as they come up. And the ideal policy environment is one that lets people do that innovation and find those opportunities within an ethical framework that maybe prevents us from doing the things which are, actively bad.
Thank you very much. I'm just going to add another level of complexity here because here we go. Felipe has added into the chat a question on the role of supercomputers when we're already facing so many challenges and opportunities to universities through AI and the use of data-driven technologies. Then how do you see the role of supercomputers? What extra challenges might that bring?
Shall I go first?
Yes, please.
Add. So, I mean, it's interesting because Philip is also kind of thinking about what the impact of this is on collaboration, isn't it? And then, I mean, in the UK, a lot of the supercomputer infrastructure is collaborative. So it's national infrastructure that primarily universities have access to and are usually run by universities as well if they've been successful in bidding for them, although I think some of them are finding that it's quite an expensive thing to do and to run. I do think that although they enable collaboration, as Philippa quite rightly points out, they also often run on a relative competitive basis because they need to pay for themselves. So people need to bid for the time. It's like getting research money. You have to bid for getting access to the supercomputer piece. I see them basically as a potential big enabler of allowing large data sets to be crunched through AI type tools. I think they will enable a speeding up of it, but they're not going to be a fundamental changer of what we're doing. They're not going to change, I think, the way that we look at AI in any way, form, or shape. But then again, there may be things that we can't predict that may come out of that. But yeah, I'm not sure it's going to be a huge differential factor in either collaboration or in AI development.
No, this is a very good point. But at the same time, there is this worry of this sort of exponential speeding up of innovation. Kind of where could that lead? Cameron, what are your thoughts?
I think there's sort of an interesting political and resourcing challenge here in terms of, well, what do we mean by a supercomputer? So the kinds of, as I understand it, again, this is not my area of expertise, so if anyone feel free to correct me about this. My understanding is the kind of supercomputers that have been built for climate modelling. So the massive high-level processing style computers are not the same as the data centers with massive sets of GPUs that are being used to process language models, and are not necessarily the same as the sort of more traditional 1,000-node clusters for parallel processing. And so there's a risk or a risk opportunity problem that arises if suddenly, as we quite frequently do, everyone's attention is over here on, oh no, we need a UK centre for GPU clustering to be a supercomputer leader, an AI leader in the world or whatever. And actually, we forget the fact that this computer over here that's doing the climate modelling, now the Americans have stopped, is actually really important for a variety of reasons. And it doesn't get resourced, and not just it doesn't get resourced, but that isn't an area that the next generation of scholars goes into. There are risks there to think through. So that's kind of, I guess, the negative or the concern. I think the flip side is, if we're thoughtful about having a diversity of capacities and infrastructures, and there is some competition for resourcing, so there's some balancing out of where these things are and who has access to them, then we set ourselves best up for the challenges and opportunities of the future by having a diversity of capacities and systems in place. So I think there are potential opportunities. Obviously, if you happen to be at a university that happens to have the right kind of computational infrastructure, you're going to have an advantage with this at the moment. And I think we just need to be careful to try and avoid the classic problem of chasing whatever the latest shiny thing is, and think about the ecosystem as a whole and the qualities of that will help deliver the capacities we need for a complex future.
Thank you very much. And on that note, I will wrap up, because we cannot predict what will happen, and we're in risk of scaring ourselves, I think, at the moment. So we've discussed so much, and I've learned so much. So thank you very, very much to our panel, Astrid, Cameron and Devika, who unfortunately couldn't stay with us to the end, but nevertheless added a lot of richness to the debate. We've discussed lots of challenges and opportunities, making sure that data is available, shareable, reproducible, and kind of all of these things that kind of allow these technologies to work. But also, how do we make the entire process transparent, so that there is trust really within the system as well, along with the opportunities and the influence on how we do research and how it could be structured going forward. And we've seen some really exciting examples of that as well from our panel and audience. So thank you very much. Anybody that's not been monitoring the chat, there is quite a rich discussion there that's been going on within the chat. There's lots of information that's been shared, and we will collate all of that and we will send it out to our audience and everybody that signed up afterwards, so you will have access to that. I would like to just do a little plug for the Ethical Data Initiative, because we do have our town hall meeting coming up on the 27th of November. And if you are interested in this, you'll probably be interested in some of the discussions that we will be having there. And we will be launching our new topic around recommender systems there as well. So there is a fair number of links really between the sort of things we've been discussing today and the research of Sylvia Milano and of Stefan Guttinger, who are our heads of research based at the University of Exeter and in the Technical University of Munich. So Sashith, if I can ask you please, I think you are still there, to drop a link, thank you very much, into the chat. But we will send it out as well to everybody who has signed up here today. And it's a really good way of getting involved in the community and having your say as well in our activities. Additionally, our partner organisations, if you'd like any information on the Coalition on Advancing Research Assessment and how you can get involved and how you can help your institution to sign up to that, or the Declaration on Research Assessment as well, then please feel free to get in touch with me and I'll help plug you into the right people and get you the information that you need on that. So a massive thank you to our panel and to everyone behind the scenes who have helped me set this up and make this possible. Yeah, let's keep the conversation going. I look forward to seeing you all soon. Thank you.
Thank you very much, Catherine, Cameron.
Thanks
and
for
others.
organizing. Yeah.
Thank you.
Bye-bye.